A GPS does more than find a route. It also tells you when the road you need is missing. Cell state reachability brings that honest answer to cell engineering, and first we'll see why drug discovery needs it. Drug discovery pays for wrong turns late. Only about 1 in 10 candidates reaches approval, and phase 2 is a critical cliff. So before asking whether a target will cure disease, we ask an earlier, testable question. Can measured effects point the cell in the right direction? To answer that, we start with Zhu and colleagues' genome-scale CRISPR-I-perturb-seq screen in primary human CD4-positive T cells. 33,983 profiles across 10,282 genes. Each knockdown leaves a measured transcriptional fingerprint, so we use those effects as a dictionary instead of inferring a network. Next, we turn that dictionary into geometry. Non-negative mixtures of measured knockdowns form a convex cone, because CRISPR-I effects cannot simply be reversed into activation. We split the target into a reachable component and a residual, and a far cache certificate shows when that residual is provably outside the cone. Applied to the Th2 toward Th1 direction in resting CD4-positive T cells, the held-out cosine is 0.448, beyond all 60 shuffled targets. The signed split is 39% knockdown reachable, 25% activation requiring, and 35% reachable by neither measured modality, with a KKT residual near zero. That certificate becomes a to-do list. Go with a sparse CRISPR-I panel, redirect activation required genes to CRISPR-I, or stop when the direction is outside the cone. Across the top panels, we nominate 102 unique knockdown candidates. 45 lack a drug handle, while 10 already have a clinical-grade drug. So what is new here? Among 91 prior methods, 14 use measured effects in the relevant cell type, but none returns a target-specific feasibility verdict, which places this work in the previously empty quadrant. Now we test portability. Without retuning, the same solver reaches a held-out CEBP alpha state in the Norman K562 CRISPR-I screen at a cosine of 0.878. Yet across 126 measured double perturbations, agreement with the sum of singles has a median cosine of 0.71, so additivity is useful but bounded. That brings us back to the real output. Not a claim that a target works, but a decision for the next experiment. Test a focused knockdown panel, add another modality such as CRISPR-I, or seek a better measured dictionary.